Okay, now let's go ahead and get part 2 done with this lab. You've already done the domino part. You saw the pictures and the video that goes along with it. Please make sure you do the graph that goes along with it. Now we're going to go ahead and go to our motion detector lab. It says here that you're going to use this motion detector, which I brought one home here, and I went ahead and brought the little handheld part of it. Normally we attach it to or connect it to the computer in the lab, but I went ahead and brought a handheld one. It says here, first you're going to go ahead and get it all turned in and turned on, like I've already have it ready to go. And you're going to have a person who's going to be the walker, and they're going to walk in front of this actual green part, which is the motion detector. So for us, here it is right here, our motion detector. Okay, so let's keep reading here. It says here that you need to choose one person in the group to be the walker and practice walking with this equipment first, which I've got 2 people in my group over here who are going to be my walkers. Okay, let's keep reading. Now it says over here on part 3, now with the same walker who has been practicing, and they've already been practicing before we started videoing, we're going to have that same walker stand in front of the detector and create this graph right here. Okay, so we need them to create this graph. First thing is you need to decide what's going on in this graph. Okay, and before you do that, remember, when you see any type of graph, you're going to always go to the X and Y axis to determine what type of graph is it. Okay, are there other graphs besides the DT and VT graphs? There is. But the DT, VT graphs are the most commonly used in physics, okay? And this one's a DT graph. I have the line A, line B, line C, and line D, okay? So I'm going to have them walk so that way they can create that on a DT graph on my machine over here, and I'll show you. Then it tells you here what would happen if the slope of the line, on the line graph above, it says here, when the person is running. So what if I was to have my walker create this graph, but I'm going to have them do it faster? So we need to look at that, and we need to compare the two regarding the graphs, the DT graphs. But what are we comparing? We're actually going to compare the slope of the line. And then it says here, draw the new graph in blue. So let's go ahead and draw the first one. Does it tell me what color to do it in? No, it does not. So here it is over here. This is the one that we're going to create, but then we're going to create, and it says another one here, and let's do it in blue. So let's go ahead, if you're watching, because you should be watching this so that way you can get your lab paper done, we will go ahead and do the first one in black. The first one is going to be creating this graph, okay, but it's going to be walking steadily, and it's going to be a DT graph, and we're going to go ahead and draw out what we get. Then we're going to do it again, same steps or the same motion of this DT graph, but we're going to go faster, and we're going to go ahead then and do that in, let's say, blue. Okay, so black and blue are what we're using. Please, I hope you've been looking at this lab because they actually are color-coded for different sections. Please use the correct colors that I'm asking you, okay? So let's go ahead and get started. Let me get my helper. Capri, you're going to be first. I'm going to need you to stand over there at the second meter, at the end of it. Yeah, right there. I'm going to go ahead and record you. And I've got the motion detector over here. Let me move this paper out of the way. But the most important part of it is to actually have our graph itself. Oops. And we're going to use this LabQuest to do that so we can create our graph. Oops. Let's see. Oh. So here's the LabQuest. Let me turn it off. Let me, oops, clear that out. Okay. So I need to move my LabQuest out of the way. I just wanted you to see it so you can see this is what it's going to look like. I will show you the actual graph here that's created after, okay? So let me go ahead and get her walking so that way my motion detector can can grab her. Capri, I need you to listen to my directions, and then I need you to follow what I'm going to tell you in just a moment. Okay, you're going to walk regular step. You're not going to go crazy fast. Okay, you're going to walk regular. You're going to walk all the way to, from there all the way to here where my motion detector is, right? And don't touch it, but walk in front of it. Then you're going to walk backwards, same speed, not any faster, and you're going to walk backwards all the way over there. Do you see where the meter, those 2 meter sticks right there are touching? You're going to walk backwards back over there to that spot right here, and you're going to wait, and then you're going to come back, and you're going to come back to this point right here, okay? So I'm going to say walk forward, walk backwards, but remember, you have to do it all in the same speed, okay? Let me go ahead and start here. When I say ready, you're going to walk all the way to me, walk backwards halfway, and then walk forward to that point right there, okay? Ready, set, go. Walk, 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 walk. Now walk backwards. Stop, 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 rest, don't move, come forward, 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 stop. Okay, go back and do it again. Hold it, let's clear that out. Okay, get ready. We're gonna do this again. Ready, set, go. Walk to me, to me, to me. Keep coming, keep coming, keep coming. Go backwards quickly. Go, go. Stop, stop, don't move. Come back forward, 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 forward. Okay, the problem is, I've got to